All right, clip number 3 on chapter 10, test preparation. In this clip, I'm going to cover the last 3 questions of the chapter test. This first question we're going to cover is number 8 on the chapter test. It's going to be referenced directly in section 6. Section 6 was about segment relationships in circles. This was very, very subtly related to section 5. The last problem of the last clip, section 5, was about angle relationships. So fundamentally, the answers there were going to be in degrees. In this section, now we're talking about segment relationships, which means we're talking about distance or length. And similar to the section 5 demonstration, there are kind of options here. There are going to be different variations of what you might see. So I'm going to show you how to set up the correct equation for the variation that you might see. So segment relationships, it really depends on finding the segment length where the segments intersect. And so there are, again, 2 scenarios that you're going to either see, depending on the version of the test that you see. So ways that segments can intersect in or around circles. I could have, just like in the last one, I could have them intersect somewhere on the inside of a circle, creating this X scenario. And let's give labels to these points. We'll call this A, B, C, and then D, E. All right, so if I have segments that intersect on the inside of a circle, I get this kind of X scenario, X-Men symbol, whatever you want to think of it as. Okay, but I get this situation. Now, when it comes to segment length, we're talking about distances between, say, A to B, or A to C, or E to B, E to D. Well, lots of different ways to combine things here. But we're talking about distance now, not angle measurements. So fundamentally, there'll be a different type of question. Number 8 in your chapter test will ask you about some segment length here. Now, I want you to notice something. There are these segments are 2 different chords. Chord A to C, a segment with endpoints on the circle, and chord D to E. And what we learned in section 6 was that if I take each of these individual chords, chord 1, we'll call AC chord 1, and chord 2, DE, if I were to take the pieces of each of those chords and multiply them together, they have to equal each other. So setting yourself up with the following equation. Again, the letters will be different. The letters will be different on your chapter 10 test. What's going to be more important is identifying which pieces are which. So let me start with the first chord here. It doesn't matter which one's the first chord, but let me start with chord AC here. The pieces of AC are AB and BC. If I multiply those pieces together, again, for chord number 1 here, I could have started with chord DE for the record, but I started with this one. That's going to equal chord number 2's pieces multiplied together. And the pieces of chord number 2 here would be D to B and then B to E. As long as you can set yourself up with this equation, it's essentially going to boil down to collection of like terms and then solving for a variable. Now, this will be one that after the clips are finished recording, I'll make sure I demonstrate this one because this one can get tricky because if I get algebraic phrases for these guys, I could end up with some polynomial multiplication. There is a demonstration of that in our section notes, so you can always look back at the solutions for that to see it worked out during the test. Okay. So again, the first situation I could see here is I could have segments that intersect on the inside of a circle. In which case, again, I can think of this like, again, if you need to have little descriptions for yourself off to the side. This is chord number 1. This is chord number 2. And this is just it broken up into the pieces that make up that chord. Okay, they fundamentally will cross each other and split each other into a couple pieces, multiply those pieces together for each individual chord, and set them equal to each other. Okay, situation number 2. It'll be one of these 2 situations for your chapter test. Situation number 2. Now what happens if I get my chords intersecting on the outside of a circle? All right, and again, I'll label points here. So we'll call this A, B, C, and then D, E. So now the intersection's happening on the outside. You'll notice that this looks very, very similar to what we just did in section 5. The difference here is now I'm going to be asked about segment length or distance rather than an angle measurement. So again, it's just about setting myself up with the proper equation. And so in section 6, for an outside intersection, it basically broke down into the following formula. I have two segments here, and what we would call secant segments because they extend beyond the circle. Okay, but I have two segments here. So we'll call this segment number 1, A to C, right? And we'll call this segment number 2, E to C. So if I take the outside piece times the whole segment of segment number 1, it has to equal the outside piece times the whole piece of segment number 2. So in this case, outside piece would be C to B, or B to C, however you think about it. I'm going to multiply it by the whole segment length, C to A. And that has to equal segment number 2, the same situation. Outside piece, C to D, times the whole segment length, C to E. Again, you'll see problems with this worked out in section 6 solutions, so feel free to look at that. Again, this can get a little bit more complicated in section 5, because if I have algebraic phrases in for these pieces, now I'm dealing with polynomial multiplication. And that's a semester 1 reference. So again, if you need to see those things worked out, we can revisit those after the recordings are finished. Or again, you can just double check in your section 6 solutions to these, because you'll see both of these worked out. I think it's this one that you see one where it's like every one of these is an algebraic phrase, and there's lots of polynomial multiplication demonstrated in that solution. Okay, but in your problem number 8, it's going to be one of these two scenarios. So if it's on the inside, the intersection's happening, it's chord number 1, chord number 2, each piece of each chord is multiplied by each other. If the intersection is happening on the outside, like in this case, it's outside piece times the whole segment equaling outside piece times the whole segment. All right, but that'll be problem number 8 on your test. All right, let's keep going. Problem number 9, our penultimate problem on our chapter 10 test. This is going to be referenced, these last two problems are going to be referenced in section 7. Section 7 was circles in the coordinate plane. And problem number 9 specifically is going to be a very, very fast one. Okay, so this is problem number 9, and I'll just give you an example right here. Okay.
Happy Staff Appreciation.
Thank you.
You're welcome.
All right, so in problem number 9, you're going to get an equation of a circle, like you see here. And the punchline of chapter 7 was that this was the main focus of the section 7 notes, was built around the equation of a circle, how it would translate this given information into a graph on a coordinate grid. Now, for problem number 9, you're not going to have to graph anything. I'm simply going to ask you for two pieces of information. Identify the center of the circle that's expressed here and this circle's radius. In regards to a circle in just free space, no coordinate grid whatsoever, the only real measurement that's going to matter is the size of the circle. And the only measurement that we really need for a circle is its radius, the distance from the center out to its outer edge. But as soon as I involve a coordinate grid, location matters, and that's where the center will matter. So as long as I know the center location of a circle and the size of that circle, I have everything I need to graph it. And so that's why this equation right here is really handy, because all that information, both these pieces, is expressed here. So center, the one thing to maybe keep in mind is that this has to be a coordinate point. It's going to be an XY combination. Radius will be a distance. I'll work through that in just a second. But first, let's identify the center coordinate point. And the simple way to approach this is that basically I'm looking to see what's attached to the X and the Y. What number is inside the parentheses? Now, keep in mind we did a couple of examples where there was no parentheses. It was just like an X squared or just a Y squared. Technically, there's a number there. That number just happens to be 0. Okay, if it's just X squared by itself, technically it's like saying X plus 0 squared. We don't write it because it's just redundant, but that would be a case where there is a number there. We just have to be aware of it. So for this XY coordinate point, the X version, unsurprisingly, is going to be whatever's attached to the X. Now, here's where you need to be careful. And the kind of shortcut hint here is that I'm going to just take the opposite sign of whatever's in the parentheses. More technically and exactly speaking, it's whatever would make this parentheses equal 0, because technically I could have something multiplied by the x, but that's not going to happen on your test. So for us, just take the opposite value of whatever is here. That's a positive 5, so the opposite of positive 5 is a negative 5. That goes in the x spot, again, because it's attached to the x. For the y spot, I'm going to do the same thing here, but take the opposite version here. Again, to speak exactly, it's whatever would make this parentheses go to 0. For us, that's just going to be the opposite of whatever that piece is. So that's a negative 3. That's going to turn into a positive 3. There is my center location of this circle. For the radius, or the size of this circle, that is expressed by this side of the equation. But it's not just this number. The basic form of the equation of a circle, this side of the equation is r squared. So I do need to do a single step here. I need to take the square root of whatever values on this side. So in this case, I'm going to take the square root of that right side of the equation. In this case, it's a 9. This one's a nice friendly result. Square root of 9 is just 3. So this is a circle that's located at negative 5, positive 3. I would go left 5 and up 3 if I had to graph this, and then just go 3 units in every direction. There's my circle. Pretty quick, fast, and painless for problem number 9 here. Just identify the center and the radius of the circle. You do not need to graph it. If you do get an unfriendly number here for taking the square root of, I'll make sure I tell you whether or not you're just simplifying that radical, or if I'm going to have you round to the nearest 10th, 100th, or whatever. Okay, but you can expect that sort of result for your chapter test. That's problem number 9. All right, one more problem to go. This will stay in section 7 on circles in the coordinate grid. But in this one, the flip side of the coin of what we just did. In this problem, in problem number 9, I gave you the equation of a circle. I asked you to extract out pieces of information that we would need. Now for problem number 10, I'm going to give you pieces of information and ask you to build an equation. So for instance, this is again taken from our section 7 notes. In this case, I tell you the center coordinate point of a circle, say at -1, +3. But I don't tell you the radius. I give you some other point on the circle. In this case, say -5, +6. And I ask you to write the standard equation of a circle, meaning I need to write it into the following format. Okay, so this is the standard format for the equation of a circle. This is in your notes already. Oh, that should be minus. And in order to write the equation of a circle, I need 2 pieces of information. I need the center coordinate location. We are given that. This piece right here will simply be plugged in to this left-hand side of the equation. But the second piece of information I need to know is the size of the circle. I need to know r. In this case, I am not told r specifically. In this case, I am just simply given another point. But if I can find the distance between the center and this outer point, that tells me the radius. Enter the distance formula. And so here, again, make sure you have this written down so you don't have to memorize it. I'm going to burn through this pretty quickly. Radius is going to equal the square root of the following: x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Again, x1 and x2, y1, y2 are just going to be dependent on what those coordinate points are. It does not matter which one's coordinate point 1 and which one's coordinate point 2. Just stay consistent with it. So for instance, if I call my center point 1, that's going to be x1, y1, and this would be x2, y2. I'm going to plug those values in for their respective variables in that distance formula and solve for r. Okay, now in this case, I'm going to tell you that the radius in this, I'm just going to jump to the conclusion. I'm going to skip working through that distance formula for the sake of this recording, just so that we can get to it. So ... you go through the effort of plugging stuff in and doing this. Radius came out to be the square root of 25, or r equaled 5 in this case. And so once you get to that result of what your radius is, now I just have to plug it into that formula, this x minus h squared. So here I would plug in that -1, +3 center, and now the radius location